Voyager 1 was supposed to enter empty space. Instead, it hit something. More than 15 billion miles from Earth, beyond every planet, beyond Pluto, beyond the reach of the Sun itself, humanity's most distant spacecraft encountered a boundary that shouldn't have looked the way it did. Scientists expected a slow fade into darkness. What Voyager found was a wall. For nearly 50 years, Voyager 1 has been drifting farther and farther from home. It is the most distant object ever built by human hands. A lone machine crossing a region no human being will ever see with their own eyes. Its mission seemed simple: leave the solar system and enter interstellar space, the vast ocean between the stars. But when it finally reached the edge of our sun's influence, something strange happened. The spacecraft's instruments recorded an abrupt and violent change. Solar particles that had surrounded Voyager for decades suddenly vanished. At the exact same time, high-energy cosmic radiation from deep space flooded inward. Scientists expected a gradual transition. Instead, it felt as if Voyager had crossed an invisible border, a border separating two completely different worlds. This boundary is known as the heliopause, the true edge of our solar system. For decades, astronomers imagined it as a chaotic mixing zone, a region where the solar wind slowly blended into interstellar space. But Voyager revealed something entirely different. The boundary was shockingly thin, sharp, structured, almost like a wall standing between our star and the rest of the galaxy. And that discovery created a problem, because according to existing models, it shouldn't have looked like this. Then things became even stranger. Scientists initially wondered if Voyager's instruments were malfunctioning. Maybe the readings were wrong. Maybe the spacecraft had crossed through an unusual region. But 6 years later, Voyager 2 approached the heliopause from a completely different direction. And it found the exact same thing: two spacecraft, two different locations, one identical result. This wasn't an error, it was reality. Something was shaping the edge of our solar system in ways scientists did not understand. Imagine standing inside a giant bubble floating in the middle of an ocean. Inside the bubble is everything familiar: the sun, Earth, every planet you've ever known. Outside the bubble is the galaxy itself. For years, we assumed the bubble simply faded into the surrounding ocean. Voyager revealed the truth. The galaxy is pushing back hard. The solar system is not floating peacefully through space. It is moving through the Milky Way, while immense pressure from interstellar space presses against it from every direction. Voyager's measurements revealed that the region beyond the heliopause is significantly denser than scientists expected. That means our protective bubble is under constant pressure, being squeezed by forces we cannot see. The heliosphere isn't a perfect sphere at all. It is distorted, compressed, stretched, shaped by invisible currents flowing through the galaxy. And then Voyager uncovered another mystery. Scientists expected the magnetic field of the Sun and the magnetic field of the Milky Way to collide violently at the boundary. The result should have been turbulence, chaos, magnetic confusion. But that isn't what Voyager saw. The two magnetic fields appeared far more aligned than predicted, almost as if they were interacting with each other in ways our models could not explain. The deeper scientists looked, the more unsettling the picture became. The edge of our solar system wasn't random. It wasn't chaotic. It appeared organized, structured, controlled by physical processes we still don't fully understand. And this discovery isn't just important for astronomy. It may directly affect the future of humanity, because the heliosphere is more than a boundary. It is a shield. Every second, high-energy cosmic rays race through the galaxy at nearly the speed of light. Many are born in ancient supernova explosions. Others come from violent events occurring across the Milky Way. Without protection, this radiation can damage electronics, threaten astronauts, and alter biological systems. The heliosphere stands between us and that cosmic storm. For billions of years, it has helped protect our corner of the galaxy. But Voyager revealed something scientists had underestimated. That shield can change. As the sun travels through different regions of the Milky Way, the pressure surrounding the heliosphere changes as well. If our solar system enters a denser interstellar cloud, the heliosphere could shrink, and a smaller shield means more radiation reaching the inner solar system, possibly even Earth. Some researchers believe events like this may have influenced Earth's distant past. The evidence remains debated, but Voyager has given us the first real clues, the first direct measurements from the space between stars, and that makes its final discovery even more heartbreaking. Voyager is dying. Its power source is slowly fading. Engineers have already begun shutting down instruments to keep the spacecraft alive. One by one, its systems are falling silent. Humanity's only witness beyond the solar system is running out of time. Every signal arriving from Voyager today could be among its last. Yet even in its final years, the spacecraft has transformed our understanding of the cosmos. It proved that interstellar space is not empty. It is magnetic, structured, pressurized, alive with energy. The darkness beyond our solar system is not a silent void. It is an active environment, locked in a constant struggle with our sun. And perhaps the most unsettling part is this: Voyager has only traveled a tiny distance into that enormous ocean between the stars. If the very edge of interstellar space contains mysteries we still cannot explain, what else is waiting farther out in the dark? The truth is, humanity has not left the cosmic shoreline. We have barely touched the water, and the galaxy is already pushing back.